yes, as an industry, we love making things hard. As an industry, as individuals, it's human nature to overplan, to over-provision, to think too many steps ahead, and especially from my experience, to assume we know what we don't. Because when we use complexity to mitigate complex problems, solve complex problems, then we're doing a great job, but quite often we fail to spot the real problems.
This is DevOps Paradox, episode number 255. What is developer observability? Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, when we've been working with observability in the past, we've usually been going at it from the operations side, right?
Because only ops care about observability.
But is that true?
Partly. So let's put it this way. I think that everybody should care about observability. But then many were disappointed enough with observability that stopped caring about it.
So on today's show, we have, please forgive me, here we go, I'm going to try it, Liran Haimovitch on from Rookout, which we'll get into a little bit more. Did I even get your name close?
That was pretty good.
All right, good, thank you. That's I tried to do it right. Say your first name correctly for everybody listening.
Liran.
I cannot roll my R's like that.
No, but you were pretty close, trust me.
Okay, well, thank you. We said Rookout, but since the time of Rookout, you were the CTO for Rookout. Rookout was acquired by Dynatrace towards the end of 2023, and you are now a product architect within Dynatrace. Is all of that correct? Okay, good. All right, all the check boxes are checked. Hopefully everybody's happy with that explanation. Now let's move on with the show. Now, I may be referring back to Rookout because what you're doing within Dynatrace is bringing what was Rookout into Dynatrace, correct?
Yes, in many aspects, yes.
In many aspects. So if I say Rookout or if I say Dynatrace as you're listening, trust me, it's what we're all talking about the same thing. So if you're familiar with Dynatrace as being the normal monitoring and everything else, put that to the side for the moment, right? Because we're going to focus on what Rookout is bringing into that. Okay. Everybody's good with that, right? Everybody understands. Everybody's got the check marks ready to go. Okay. So what we're talking about here is about observability, but the way that Rookout was always looking at it from the beginning was developer observability. Now, my question is, why do developers even care about observability? Because it is just so freaking different. You know, what the thing is that I need as a developer, at least 20 to 50% of the time is going to be different than what an ops person is going to need.
Yeah, so at Rookout, we've been passionate about developer observability from day one. And I would say that for many developers, they don't care about observability. The easiest thing is not to care about observability. The easiest thing is to focus on the code on your machine. Just write the code, run it in a unit test, spin it up on your laptop. Everything is good. Why bother with everything else? But it doesn't really matter. It doesn't really matter if your code passes the unit tests or the end-to-end test. It doesn't even matter if the code runs properly on your machine. What really matters is the code operating well for the end customer? Is it operating well in production? Is it operating well in the cloud? Is it your SaaS product delivering whatever it's supposed to be delivering? Those are the hard questions, and those are the important questions. And I think as an industry, we are realizing that because the whole shift left movement is all about get developers out of the lab, get developers to care about their code in the real world. And how do you expect to do that if they have no idea what's happening in the real world? And that's what observability is all about, and that's why developers really should care about observability, and why even more so their architects, their managers, their leaders, their business stakeholders should all desire and advocate for developers to partake in observability.
A big problem, at least for me, was when I was more into the dev side, is that I saw two distinct type of cases, and neither of those worked for me as a developer back in the day, is that either I have no access to production observability data, right? Because that's reserved for the selected few individuals, or I have access to all, right? And then I get access to 99% of the things that I don't understand, because my application might be failing because I messed up something, or it might be failing because external load balancer that I never saw in my life is failing, right?
It's always DNS. Something failing, it's always DNS.
Exactly. So my question is, how can we provide the right information to developers, right? Not be in either of those two extremes. Give them what is related to the application.
I agree. I think it's super important that we understand that as important as we want developers to focus on observability, they are a different type of user, they're a different type of consumer. They often need different data, different tools, different context than observability practitioners. Even more so, at the end of the day, developers don't spend their working days in production. They don't spend their working days in Prometheus or in Dynatrace or wherever. They spend their working days in their IDEs, sometimes on Slack, sometimes in their CI/CD tools. They live in their code. And because they're not observability practitioners, we can't force them to study hours, days, weeks, and months observability. Just like when we expect developers to care about security, we make it easy for them to use in bite-sized feedback, such as this package is out of date. Please update it to that version. That's a small nugget. That's something that's easily understood.
That never happened. What you just said. The developer was notified that there is a package that is out of date. If developer doesn't receive 100,000 or 1,000 vulnerabilities in one go, security doesn't work well.
That's another problem. But let's keep this episode about observability, because if we get started on security, we're going to get so many different directions. So we really need to keep this focused. We need to have intuitive tools that speak developers' language, that make the data they need easy to understand and very focused, because there are amazing gems that developers can find in observability data, whether it's about how do I fix these bugs half my customer base is complaining about. That's never happening anywhere but production. How do I optimize this piece of code to run 10 times faster? Can I deprecate this feature? How do I redesign this interface to run much better if I don't know how it's actually being used in production? Developers can always come up every day with dozens and hundreds of questions about how their code is actually being used, how their code is actually executing, and the only way to provide real answers to those questions is using high quality observability data. And just like you pointed out, Victor, the very first thing is about giving them access, doing that in a controlled and a secure manner, and making sure that they understand it. We can't expect them to go through a 1-month training period to make a sense of the observability data. That's just not going to work. We need to make the data accessible for them on their own terms.
So what we're saying is developers are special and we need to cater to them all the time because they are incapable of learning how to do anything else.
That's another way of looking at it, which is, in some ways it's true. In other ways, think about it, it's not their day job. They have tons of other things to do. Besides observing their code in production, they have to write new code, they have to design features, they have to fix bugs. It's just one more thing on their task list. If we require too much of them, like any other stakeholder, any other profession, they're just going to give up on that. I can't argue that sometimes developers have very short attention spans and want to make things work very quickly, or they can easily give up. But at the same time, they are quite often overloaded, as Victor said, with hundreds, if not tens of thousands of security vulnerabilities and bugs and questions and documentation out of date and so on and so forth. So we do need to make the data easy for them if we want them to pick up that extra skill of observability. I can give you an example. At Rookout, our key offering was a live debugger. We took the traditional debugger experience that developers love and are accustomed to on their laptop, and we adapted that experience to the cloud. We adapted that experience to production so that developers could literally point on any line of code, whether they could do it on their IDEs or in the web, and they would instantly get snapshots that would look exactly like debug events whenever those lines were being hit. So instead of trying to debug the code on your machine, you could easily debug the code in production. You could reproduce and observe bugs that are seen by customers. You could see how often the code is being hit, what are the values of the various variables, and so on and so forth, all using an experience that most developers have been using for years, sometimes decades, are intimately familiar with. And it's also much better suited to answer the average question the developer would ask, rather than optimizing the experience for ops people, as you mentioned earlier in the episode, which are super important consumers of observability data, but they're not the only consumers.
I want to go back to the point that you made. Developers don't spend their days in production or in Prometheus or any of the other monitoring tools. They live in their IDEs and some sort of communications tool. You said Slack. It could be email, Slack. It doesn't matter. They're communicating some way in near real time. When people think that developers just want to add another tool to their tool stack, how off base are they?
So that's a challenging question. If you look at individual developers, most of them are gadget geeks, and developers just love most developers I know love getting their hands on new gadgets, and they will just love to experiment with everything. If you look at the organizations, on the other hand, and developers teams, developer organizations, engineering organizations, they are much warier about adding new tools to their arsenal. There is pretty much a lot of tool fatigue. Every new tool comes in with security risk, compliance risk, performance risk, training overhead. And even if you've got through all of that, if nobody remembers the new tool is there to use it, nobody's going to use it anyway. So you've just went through spent all the time and effort and money to adopt a new tool. But if nobody remembers it, nobody uses it, it's going to go down the drain. So organizations as a whole are very picky today about which tools they adopt. You need to either go through to prove that it's a big problem, and that's going to make a huge difference, like we feel developer observability is, or organizations will often prefer to stick with existing platforms and try to source additional features from their existing vendors, from their existing platforms, which often comes with much smaller hurdles when it comes to adoption, when it comes to training, because it's much easier to get more out of the same tool, which is a great part of the synergies we're seeing within Dynatrace, as it's such a robust and extensive observability platform. Putting developer observability as part of that is a huge win for many organizations.
Who's the buyer of developer observability type of tools? When I say buyer, I mean, who is the persona that comes to Rookout and says, we need this? Is that a developer?
So it's often developers. Developers, usually when we do demos at conferences and stuff, it's literally jaw-dropping. I love the experience of demoing Rookout to people because they're literally shocked. They think it's some kind of magic. They think it's unbelievable. They just don't believe me initially, which is why live demoing is so much fun. The experience of being able to see into the code wherever it's running is mind-blowing for many developers. And so every developer who sees the tools loves it, wants to use it, at least from my experience. Usually in larger organizations, you would be seeing tech leads, architects, engineering leaders, and in many cases, supporting functions as well, whether it's productivity engineering, platform engineering, people who are in charge of the tools developers are operating, people who are in charge of production, transition to production. Obviously, observability practitioners are very eager about these tools because handovers are super tricky. If, let's say, somebody identifies a bug, whether it's ops, whether it's support, they see the bug, they try to communicate it to engineering, and quite often they don't have a lot of context. This user has this bug in this case, and today systems are so complex, it can be very hard to narrow down what makes the bug reproduce, what's relevant. From my experience, 9 out of 10 times, developers would say, I can't reproduce it. I'm not sure what to do. They would sometimes add a log line, which can easily take weeks or months to be deployed, depending on the release cycle and the security and so on and so forth. And in the meantime, everything is stuck. Now, if you look at the live debugging tool, a customer has an issue, data is missing, just throw non-breaking breakpoint in there, and within a matter of seconds, you're going to get additional data. And this data is going to be so much richer than any log line you've ever seen. It's going to include the entire stack trace, every variable value. It's going to include the server information. It's going to include the tracing information. And you can easily shift it. You can add conditional breakpoints. You can add breakpoints. You can remove breakpoints. You can move them. You can jump between services, between microservices. You can debug serverless. You can debug Kubernetes. You can debug. You can jump between repos and programming languages. You can shift as easily as you choose, as you essentially run this investigation. So you can collect data agilely as you're investigating. Collect more data. Adapt your approach and respond to feedback in real time instead of just groping blindly at, as you mentioned, mountains of irrelevant and hard to search through observability data, or continuously waiting for new log lines to be deployed for more data.
You stated there systems are so complex. Is this part of our problem? We just love making things hard, so therefore we have to keep slapping on more tools to try to figure out why we're making things so hard? And it's a self-fulfilling prophecy?
I think the answer is two prongs. First, yes, as an industry, we love making things hard. As an industry, as individuals, it's human nature to overplan, to overprovision, to think too many steps ahead, and especially from my experience, to assume we know what we don't. Because when we use complexity to mitigate complex problems, solve complex problems, then we're doing a great job, but quite often we fail to spot the real problems. Quite often as an industry, we make up problems because we want to use a cool new tool, or because we're not sure, or because we've solved a similar problem in the past, or quite often I've seen engineers trying to fight the previous battle. They've built a big system, it had some failings, and they assume that the next system they're going to build are going to have the same failings and overcompensate for that, even if the two are relevant. But at the same time, let's not kid ourselves. Software is eating the world, as everybody knows. We're building more and more complex systems. We're building systems with more functional requirements, more non-functional requirements, higher availability requirements, higher performance requirements, higher scalability requirements. All of a sudden, data governance became an issue. Now, new SaaS products are not supposed to be just in one region. They're supposed to have many regions to support data governance and availability requirements. They're supposed to integrate with anything and everything. And as we're trying to solve more complex problems, obviously our solutions become more complex. And new tools are a requirement to help us narrow down complexity, whether it's around development tools, debugging tools, whether it's about new platforms, whether it's about new programming languages. By creating better abstractions and better tooling, it's the only way we can manage the necessary complexity. Well, obviously, the unnecessary complexity should be avoided like the plague.
So what is better tooling? I think we've already sort of talked about it. If you're trying to add things in for somebody to use, it needs to be where they are already today, unless this is something completely paradigm changing, correct?
Yeah, so when we think about developer observability, there are a few things we try to focus on. One, it's around location. We want developers to stay in their IDE as much as possible, or if not in their IDE, then in their communication tools, in their collaboration tools. We want to be as close as possible to their existing tools, and we want to stick with the paradigms they know. Developers spend most of their time working with code, so you want to make sure that every insight, every observability data we bring them is connected with the code it's coming from. A logline is so much more powerful when you see it in the context of the code it was written from. An exception is so much more valuable when you see it in the context of the code it was thrown from. A snapshot, like we've discussed around breakpoints, it means the world if you know which code it came from. And by bringing this into the code, we help them understand what they're seeing and make sense of the data. Because going through Prometheus graphs without understanding where the data is coming from, what's the context, what's the meaning of it, is so much harder. And a third point is really about the learning curve. We want something that's simple. We want something that a layman can use. You can just jump in, start getting value out of the system. Developers are jumping between tools, have in many cases tool overload. We want to keep things simple for them. Obviously, there are advanced use case, and everybody wants to be a power user, and there are tons of super cool stuff you can do with developer observability, you can do with Rookout, you can do with live debugging, but we want to make sure that, from my experience, that's one person on a team. If you have 100 developers, maybe 5 of them, 10 of them are going to be power users of observability or any other tools. But if you want to true success with developers, if you want developers to really care about observability, you need 90 out of the 100 developers to learn how to use the tool, not just 5. And that's super, super, super important. I think last but not least, it's really about agility. If you look at ops, they tend to ask the same questions day in, day out. Is my system up? Is my system responding quickly? Is my system responding without errors? Those are 3 key metrics you want for every endpoint, and you want the average, and you've got yourself pretty good coverage. And if you're looking at business level metrics still, they tend to be fixed day in, day out. Developers get new engineering tasks on a daily basis, and so they ask new questions on a daily basis. How often is this code being called? What's the value of this variable? Is this even invoked in production, or is it dead? Why is this customer getting this answer where everybody else is getting a different answer? To help mitigate, we need a much more dynamic system. It's not just about collecting the same data day in, day out, having nice dashboards, and responding to anomalies. By the way, which are all super complex problems with ops engineering. But the thing is, developers just need different things. They need the ability to ask different questions quickly. They need to be able to pinpoint the data they care about. As Victor mentioned, it's a huge mountain of data. I need to be able to pinpoint a new piece of data and quickly get it. And quite often, this data is not already being collected. So I need to be able to adapt the data being collected to my needs. I need to be able to search for the data that's being collected and answer the questions I care about right now. And maybe tomorrow, I won't care about this data at all anymore. Again, very different than the ops traditional use cases and mindset.
But for all that to work, the step before all that is probably to distinguish, okay, this is a problem that is directly related to a developer that wrote the code, or this is a problem of something else, right? How do we pass that first step? How do I find out that, okay, I know that this is misbehaving. How do I know in whose domain that misbehavior falls?
Part of the joy of joining such a large company as Dynatrace is there are so many other tools besides what we've built ourselves. I mean, Rookout is great agents, great debugging technology, great user experience, but Dynatrace has been in the business for so many years, and there's so many other tools. They collect a wealth of data way beyond anything we've ever collected around the infrastructure, around the load balancers, around the DNS, around the databases, about the hosts themselves, so much more. And they really know how to connect the dots well. They know how to get a great map of how everything is interconnected. And then they use a bunch of AI models. I can talk about predictive AI and causal AI and all of that, but I'm not much of an AI expert, so I won't bore you with the buzzwords. I've never been much of a buzzword fan. But essentially, they have very fancy AI models. They call them Davis AI that help you both to understand when something is going wrong, as well as group everything that's related to the incident and identify the root cause of that. And I've seen some pretty amazing implementations of that technology. And so that should give you a pretty good head start about this service is malfunctioning. It's malfunctioning because the network load balancer is going wrong. It's failing because this deployment is bad, or it's failing because an exception started getting thrown and we have no idea why. So this should actually get you pretty close into where should you get started, looking at it and which tools are the best within the platform are best suited to start looking at the problem.
That makes sense because as a developer, I already have my stack of Jira tickets that I have to deal with. And all of a sudden I get a new thing. I don't want to spend 5 hours trying to find what the line or the set of lines may be. I want to be taken right to it. Whether that's AI, whether that's, who cares? It doesn't matter. The faster you can get me to that, that's what I need as a developer, because I don't have time to jack with that. I already have a backlog of things that I already have to make this next sprint.
And you mentioned those Jira tickets. How many of them actually come with enough information about what's going wrong versus how many of them are riddled with holes of missing information, of stuff you would just love to know to write the code better, to deal with the problem faster in a higher quality manner, but are left as unopened questions that maybe someday you would get answer for, maybe not. But more often than not, the missing data can be found in the observability tool if it was just accessible and easy to use for you.
When we get this information back to us, right? It came in through Slack, it came in through my IDE, and we've got all that cool snapshot look around us, right? I'm trying to understand all of this because today we're audio only, so we can't see anything. And you sort of explained it before, but can you give us an audio demo of what you would have done in a booth? Like, can you sort of explain that enough to where we can, in our mind's eye, see what's happening?
So you've touched upon briefly around, I got a Jira ticket, I got a customer complaint. Usually the first thing you would look at is you would either look at the code or at the logs. And in both cases, the initial conclusion is almost always the same. I know I'm somewhere in this area, in the vicinity of this code. This is where something is going wrong, but I don't know why. And here are a bunch of lines where super interesting stuff is happening, but nobody bothered putting a logline on it. Or maybe somebody put a logline on it and it got commented out, or verbosity was reduced because it was too expensive. But if only I knew what was happening in those handful of lines, I could easily solve the problem. Now, without Rookout, without live debugging, you would either add a logline and pray until the next release cycle that you would get additional data, or you would just give up, say, I have an endless backlog of Jira tickets, I don't have time for this, cannot reproduce, done. With Rookout and live debugging, what you would do is that you would just pop a bunch of non-breaking breakpoints on those interesting line of code. You could do it in any environment you choose. You can even set a condition to only collect the data for the customer in question, for the tenant in question, for the use case in question. And then within a matter of seconds, you would start getting data. This is what's happening on this line. This is what's happening on this line. This is the stack trace. This is how we got here. This is the tracing information about the cross-service request of how we got here. These are all the local variables. And you get the local variables in a such higher granularity. So it's not just about this is the string. How is the string encoded? Is it UTF-8 or is it UTF-16? Is it 15 because it's the number 15? Or is it the string 15? Or is it the character? And all of those, super minor details are usually the difference between success and failure, between success and disaster when it comes to machines, because I remember a quote from a while back that with machines, everything has to be perfect because computers don't try to guess. If you get everything right, then everything will work. But if you make the slightest mistake, things will start breaking. And by getting a very accurate picture, this is what's happening on this line. Tracing data, stack trace, variable values, everything in super clear manner. You just know what's happening in the code. And then you either instantly figure it out, or more commonly you say, oh, this line helps me, but it's only part of the answer. I want to know about this line and that function. Maybe I want to look at a different service. And again, if you were using log lines, each of those iterations would take you hours, days, weeks. Instead, with live debugging, you can just hop. You can add another breakpoint. You can change the condition. You can move to another microservice. You can look at another endpoint. You can make those iterations in a matter of seconds. You can easily add, remove logs, metrics, traces, spans, dozens of them in a few minutes versus spending weeks and months optimizing your observability to answer that specific questions. You don't have to dig through the logs to figure out, and you don't have to walk backwards on logs. So this is what I've seen happening so many times. I can't add log lines. So I start staring at the code, start staring at the logs, and try to connect the dots. So I can see this log line here. And those are the variable values that got from here. So maybe I can guess what's most likely to be happening on a different line based on the value of this log line. You can skip all of that. You can just say, this is what I want, give it to me, instantly get it, make a judgment call, and continue iterating.
Okay, a couple of things out of that. That was a very nice demo. Thank you. Did you swipe my badge already? I can't remember. As an operations person, when I hear you say set breakpoints in production, heck no. I am not going to let you do that. So how do we make it to where the ops people aren't freaking out?
So first we changed the name to NonBreaking Breakpoints because they don't break anything and they don't stop the application. We've actually experimented with a bunch of names, but let's leave that aside. What we do is we provide an extensive set of guardrails to make sure nothing goes wrong. Now, if you think about it, even a bad metric or a bad log line can crash the server. So observability is never without risk. I would argue that live debugging is safer than a log line. Think about logs. If you try to misformat a variable, if you try to access a missing variable, you can easily crash the server. Live debugging and those non-breaking breakpoints come with safeties. We make sure we never change the state of the application. The entire operation is purely read-only. We only collect data. Nothing we do changes. Even if the data is missing, we don't collect it. So if something requires a database access or a network access, we will never collect the data. We will skip it. We will provide sure that it's missing. If the variable is too big, we will only collect a part of it. So if you have a collection with 10,000 items and you would print that to a log line, you would get a huge log line. Instead, we only get you the first 10, the first 20 items and get you the size of the collection. We make sure we don't collect strings that are too large. We monitor the performance overhead. So we limit performance overhead to about 5 or 6% CPU on the host. So no matter how much data is being requested, it will never consume a significant amount of CPU. The latency of the individual breakpoint is usually well under 1 millisecond, so you're not going to notice any impact. We provide significant security and compliance guarantees, data masking, data governance, and so on and so forth. So we really do feel that the risks are as low as they can get. And think about the alternatives. As Victor mentioned, quite often developers just don't get access to production. What I've usually seen them do is they sit side by side, shoulder by shoulder with an ops person, and they start SSHing into machine. Or in today's world, kubectling into machine. Trust me, that's not better. That's way, way, way riskier. If somebody is SSHing into a machine to try to inspect it, try to understand what's going wrong, they can break it in so many different ways. If somebody is kubectling and editing YAML manifests to debug, so many things can go wrong. There are so many ways you can crash production and take down that load balancer. It's so much safer to use a built-in tool that you can set as many policies as you want to control the performance impact, to control which data is coming out, to make sure nothing bad is going to happen. Essentially, we do everything to make it idiot-proof, so you will never shoot yourself in the foot.
So that scenario of SSH or kubectl goes back to what you just said. Is it success or failure, or is it success or disaster? And I never heard it put that way. By the way, I'm going to steal that from you because because we do expect failure. I mean, if we're in this business and we don't expect failure, I don't know what planet you're living on. But we don't always expect disaster. So if you're SSHing in still, I'm guilty of that at times. Try not to do that, right? And I'm always trying, okay, how do I get to the point to where everything's read-only, right? That's all I want. You can't do read-only with SSH. Sorry. Well, you could, but then the machine's useless. Different conversation. The other thing you said, I sort of snickered. Computers won't guess. We're seeing in generative AI that that's not true. They hallucinate all the time. That's going to be my concern, right? Is any kind of if I hear there's any kind of AI underneath something, I'm automatically suspect. Again, this is me being an old guy. It's like, okay, if it's a machine model, okay, you're still okay. But if I hear generative AI working on it, it's like, I don't know about that.
So Rookout is a bit of a too old company. We don't have any generative AI just yet. We would love to add some because it's hippie and fun. But for now, it's mostly about providing users the tools to answer their question in the most efficient and easy to use manner. And if you look at observability, we've been focusing so much about snapshots, but there is really so much more. Logs is quite often the number one observability tool used by developers. Developers are often struggling to make sense from tracing and metrics because they're so hard to use. And our vision as a group within Dynatrace, as a provider as a Rookout, is about making all of that data, making all of that information is easily accessible for developers, making it a second nature, making sure that whenever you take on an engineering task, a code writing task, about a code that's already deployed somewhere, and we're going to provide you with insights and valuable information about how to write better code and what you should be focusing on because of how the code is actually operating in production, in the cloud, in real environment, serving your customers, rather than solely focusing on what's happening on your machine in the unit tests you're used to in your day-to-day.
I don't think we have to argue the point to operations people that developers need to have good observability, right? They just want to have guardrails in place so nothing's going to break. They don't want people to have direct access, but they don't mind giving people access in the way they want to give it. The flip side to that, though, is, especially in larger organizations, my opinion, the business application developers don't care anything about observability. They care about processing the Jira tickets as they come in. How do we help the developers change that mindset?
I definitely agree, but I think it's a chicken and egg problem. How do you expect people to care about something they can't see? How do you expect people to take ownership over something they are prevented from observing and understanding, or that they feel that the observability tools that are being given are too intimidating, too complex, and don't provide them with useful information? In my view, it's by providing the tools, we're also helping to shift the cultural barrier, which is all about the shift left movement, because we want developers to care about production. We want developers to care about what's happening outside the lab, outside of the engineering flow. We want them to care about what's happening in the real world. And there are many parts of that. It's a big cultural problem. It's about moving the KPIs from being Jira focused, such as how many tickets did you solve, to how much money did your team make for the company, how much money did your product make for the company, and how much better it is from last quarter or last year. It's about how do we change things from an engineering leadership perspective. What do we focus on? What do we get our people to focus on? And what do we test them on? Do we test them only on how well the code is being written? Or we test them around about how the code is performing in production and what's the feedback loop around that? But at the same time, it's not just about motivation speech. We can give motivation speech about shift left, about ownership and accountability all day long. If we don't empower developers to actually take matters into their hands and make an impact and see that impact, then nothing is going to change.
Let me spin that one just a little bit different. We were talking about developers, and we're staying large organization for just a moment. When we're going through all this conversation, in my opinion, what we've been talking about are the full-time employees. But you and I both know at large enterprises, 50 to 80% of the development organization staff is probably contractors. Maybe not that large, but it's going to be a large percentage. How are you going to get, they are part of your staff, but they're only going to be there for a maximum of 18 months. What do we do about that? Knowing that you have a short-timer mentality working in your team. How do you quickly get them onboarded to say, this is the norm of how we do things here?
First, I think the short-time problem is also highlighting the importance of quick onboarding and avoiding training cycles. Because if somebody is joining for 18 months and we need to train them on the observability tools, we need to find when can we train them, when can we send them to the class, how much that's going to eat of our 18 months, how many months are going to be wasted before they actually go through the training. We want tools that are intuitive, that require zero training, that they can start with on their day one. That's one. Two, I really feel that observability is super important in that regard, because if you constantly have to onboard people, then just like they read the code as part of the onboarding, they have to go through they go through the documentation, they look at the code, they see how everything connects. The same goes for observability tools, because if you're just, it's the difference between looking at the architecture of the building and looking at the building built and people stepping in and stepping out. If you have people study a building, the building is already up and running, it's an office building, and people are going in and out all day, you wouldn't just send them to look at the floor plans and make sense for that. You would send them to tour the building, you would send them to look at the building from the outside, see how many people are coming in, people are coming out, how are they dressed, where are they going, what are they doing, and so on and so forth. And this is really where observability comes in, because at the end of the day, the code is just the floor plans, it's just the theoretical construct, but how things are instantialized, how many instances do we have, which database are we using, what's the actual configuration, and how everything comes together, how people are using the building, the code we've built. This can only be seen by looking at the data and by providing better observability tools that make the relevant data accessible for the developers. We actually make them experts in so much easier time. I think a customer told me a couple of years ago that in the past, debugging and production access were so hard that only senior engineers who have been with the company forever managed to solve most of the bugs. And so those senior engineers spent most of their time troubleshooting and firefighting, and the junior engineers were dealing with the new feature development, even though that's what the senior people were supposed to be leading. The new architectural changes, the new shifts, but they were focused on firefighting because nobody else could figure out how to operate the observability tools. And they told us that with Rookout, junior engineers got superpowers. They could easily understand the code, see what's happening, and fix the stuff, enabling the senior people who've been with the company, or the lifeblood of the company, to do the really important stuff with a game-changing new technology, rather than focusing on day-to-day firefighting.
So since Rookout was acquired by Dynatrace, you're just running along happily, completely isolated, not doing anything at all with Dynatrace, right?
So we're running in two tracks right now. One is, let's get the existing Rookout products and have as many Dynatrace customers as quickly as we can. We want this experience to be seamless. And Dynatrace is this amazing single platform concept and single agent concept, which I love when it comes to observability. You just install one agent on your host or Kubernetes cluster. Everything is covered, from network traffic to host monitoring, process monitoring, APM, metrics. Everything is covered within that one single agent. And so we want the Rookout live debugging offering to be just the same as that. You install the Dynatrace one agent. You also get live debugging from here on out, and that's going to be coming out even the next few months. The second thing we are working on is about bringing everything else Dynatrace have to be more developer friendly, more developer focused. The term Dynatrace is often using is extend left. Their core base is IT ops people. They have a great product, an amazing offering, and we want to take some of that amazing technology, some of those amazing data they already have in their databases, and make that available for developer use cases. and we're focusing heavily on that. I've actually joined Dynatrace just a few months ago, and think they've pretty much built the most amazing log engine on the planet. They have an amazing log management and log analytics technology, and we're working to make that the best tool for developers when they look at logs. We are looking at use cases around profiling and exception catching and so much more. There's just such a wealth of data and analytics prowess within that platform, and we think developers can gain so much by easily accessing and utilizing that data.
So it sounds like to me, if someone is already a Dynatrace customer, they could start using Rookout today, ignoring contracts and everything else, right? Almost.
Okay. We'll be running this in March, so we'll be during the preview phase. So reach out to your account executive or reach out directly to me, and we can definitely try to hook you up.
Now, if you're not a Dynatrace customer, then what should somebody do if they're interested in trying to follow the Rookout story?
They can reach out to me at Twitter, Liran_last. They can reach out to me via mail. I'm probably sure going to share some of that on the podcast. You can just even reach out to me on LinkedIn, Liran Haimovitch, as you mentioned. And you can also follow the Dynatrace blog. We'll also are kind of building a new name for Dynatrace for developers, trying to focus more on those use cases I've mentioned and helping the developer community learn what an amazing company Dynatrace is and what an amazing technology and how it can serve them and not just IT and ops people, which has been traditionally the core user base for Dynatrace.
Now, obviously, people could go to Dynatrace and look at Dynatrace stuff, but the Rookout site, as of today, we're recording this actually on January 11th. You're listening to this if you're listening on release day, March 20th. Is the plan for the Rookout.com site to stay up for at least a while?
It is. We're planning to keep it for a while. There's just so much stuff going on at Dynatrace and so many developer potential there that we are still putting our minds to how do we make the most of it in the shortest time span. So for now, yeah, definitely the Rookout.com is still up. We still have quite a few customers who are using Rookout directly, and we are discussing having them move to the Dynatrace platform. That's going to take a while, so you can definitely reach out to us at Rookout, and we'll be able to hook you up with Dynatrace as well.
And I would assume that even when the Rookout.com site goes away, the domain doesn't, and it will redirect to the right place on Dynatrace.
I'm sure it will.
I'm making that job for you right now.
I own the domain.
Sure
Yeah, I own the domain, so you're definitely making this up for me.
Well, Liran, thanks for being with us today. Any final words you'd like to say?
It's been fun. Thanks for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.